We need to evaluate this integral where C is a circle mod z equal to 5. This is very important question. Now here we can write this denominator as 4 minus z, 4 plus z, z plus iota, right? Or if I take the negative outside, I'm getting here z minus 4. And let me write this z plus 4. And I can take the integrand to be minus z divided by this. Now this integrand is analytic, that is differentiable everywhere inside this circle, right? Except at the points z equal to plus minus 4 and negative iota. So it is analytic everywhere except these points, because at these points the integrand is not defined. And most important, we need what to take our fz, because when taking the denominator equal to 0, we are getting these points, and all these points are lying inside this circle, which means we cannot leave any factor of this denominator. We always include that factor in fz. When taking that factor equal to 0, the point lies outside the circle. But when taking all these factors equal to 0, we are getting these points, and all these points are lying inside the circle. So we cannot choose any factor among these for which the points lies outside the circle. इन तीनों फैक्टर्स में से हम हमेशा वो वाला फैक्टर न्यूमरेटर के साथ इंक्लूड करेंगे डिनोमिनेटर में फॉर एफ जिसको इक्वल टू 0 करने पर पॉइंट सर्कल के बाहर चला जाए, वो वाला फैक्टर हम एफ में इंक्लूड करेंगे. बट यहाँ पर तो सभी के सभी पॉइंट्स सर्कल के अंदर है. अब क्या करें? व्हाट टू डू, व्हाट टू टेक आवर एफ नाउ? So there are two ways to solve this question. Either you can make the partial fractions for this. This is the one way, and this is very lengthy. Other way, we can construct 3 circles. First circle will be for this factor mod z minus 4 equal to, let's say, the radius r1. Second circle mod z plus 4 and the radius r2. Third circle mod z plus iota and the radius r3. Right? We have to construct these circles at the center 4 minus iota. So let these points be the center for these 3 circles. 3 circle construct करेंगे, इन सभी points को हम center बनाएंगे. ठीक है, r1, r2, r3 रेडियस के साथ रिस्पेक्टिवली. फिर उसके हिसाब से हम fz चूज़ करेंगे. राइट, अकॉर्डिंग टू दैट वी चूज़ आवर fz. Okay, let's start with the solution. We are having this integrand. How can I write this integrand as? When taking negative outside, minus z, and here we can write z minus 4, z plus 4 and z plus iota. Now this integrand is analytic everywhere except z equal to 4 minus iota, that is plus minus 4 and minus iota. Except these points, this integrand is analytic everywhere inside the circle. And okay, which points lies inside the circle? All the points are lying inside the circle. So z equal to plus minus 4 and negative iota lies inside mod z equal to 5. The circle mod z equal to 5. Circle is having the radius 5. So all these points lies inside the circle. And now we have to construct this circle, and let's plot these points. So plus minus 4, okay, this is the 4 center, this is negative 4 and this is negative iota. Minus 1 represents negative iota. What is negative iota? It is, we can write this as 0 minus 1. Right? So if this is your x-axis, this is your y-axis. We have all these points now. Okay, let's construct the circle. Let this be the circle having the radius, the C1 circle having the radius R1. Let this be the circle C2 and this be the circle C3. We need the radius for each circle, right? Okay. So let C1 mod z minus 4 equal to R1 and C2 be mod z plus 4 equal to having the radius R2. C3 z plus iota mod having the radius R3. So center for radius R1 C1 circle. C1 circle, center for radius, let's say R1. Similarly the other ones. We are going to introduce the concept of the multiply connected regions. Okay. By Cauchy's theorem for the multiply connected regions, the given integral is equal to the sum of the integral over C1 plus C2 plus C3, right? Then for C1 circle is mod z minus 4 equal to R1. When taking the denominator equal to 0, we are getting the points z equal to 4 minus iota, right? So for C1 circle, only the point z equal to 4 lies inside the circle. So we can include now the other two brackets to the numerator with the numerator for taking it to be equal to fz. So for this integral, we are taking fz to be equal to this, right? Now when taking this denominator equal to 0, which factor gives the point which lies outside C2 circle? What is C2 circle? This one. Only and only negative 4 point lies inside this circle, and -1 and 4 lies outside the circle, right? So we have to exclude only z plus 4 from the function, let's say gz. For this integral, I am having the function fz. For this integral, we are taking the function gz, right? Okay, third one. When taking this denominator equal to 0, what is the circle C3? It is z plus iota equal to R3, this one. So only -1 point lies inside this circle C3. So we need to include these two factors with the numerator for the function, let's say hz, right? So we have chosen our functions to be fz, gz, hz for all these three integrals respectively. So let's write this. So it is your fz, the integrand over C1 divided by z minus 4 dz, plus the circle C2 having the function gz divided by z plus 4 dz, plus third integral having the numerator hz and having the denominator z plus iota dz. Is it okay? Fine. Where fz, gz, hz I have written over here. Now since all these functions are analytic inside and on C1, C2, C3 respectively, and the points z equal to plus minus 4 and negative iota are inside C1, C2, C3 respectively, it is very important to write respectively. Z equal to 4 lies inside C1, z equal to negative 4 lies inside C2, and z equal to negative iota lies inside C3. Accordingly, now we are going to use a Cauchy's integral formula for evaluating these integrals. So by Cauchy's first integral formula, we have, what is the value for this first integral? It is 2 pi iota into the value of fz at z equal to z0. Please remember the format. For the denominator, it should be z minus z0, right? So what is z0 for this? z0 is 4. And from here we have z0 to be equal to negative 4. From here we have z0 to be equal to negative iota, right? So f at z0 plus, for the second integral we have 2 pi iota into g of z0, that is minus 4. Here we have 4 plus 2 pi iota h at z0 is negative iota. Let's take 2 pi iota outside first. And now to get the values of these. So that is equal to 2 pi iota. Okay, what is f at z equal to 4? Okay, from here we get the value of f4 to be Just replace that with 4. So this is minus 4 divided by 4 plus 4, that is 8, into 4 plus iota. So cancelling this we get minus 1/2 divided by 4 plus iota. So we have here minus 1/2 into 4 plus iota. Now we need g minus 4. From here, the value of g at minus 4, that is equal to, in the numerator we get 4 divided by denominator minus 4, that is minus 8, and minus 4 plus iota. Again, if I cancel this, I get minus 1/2 divided by minus 4 plus iota. So we have minus 1/2 divided by minus 4 plus iota. And now what is h minus iota? From here, h at minus iota. Numerator becomes iota divided by minus iota minus 4 into minus iota plus 4. Let me take negative outside so that it becomes iota plus 4 or 4 plus iota. Applying a plus b into a minus b formula, that is a square minus b square. So 4 square minus iota square. 4 square minus iota square. 4 square is 16 minus iota square is negative 1. So it is 17 in the denominator. So this is minus iota by 17. Minus iota by 17. So this is equal to, okay, let's take negative outside completely. Let's take negative outside from the numerator. So we have 1 by 2 into 4 plus iota plus 1 by 2 into iota minus 4. Let me write this as iota plus 4 plus iota divided by 17. So this is minus 2 pi iota. If I take 1 by 2 common, I get, okay, iota minus 4 plus iota plus 4 divided by iota plus 4 into iota minus 4 plus iota by 17. 4 cancelled out with this. We have 2 iota in the numerator and also 2 cancelled out with this. We have only iota now. Let's take this iota common from the numerator. It becomes iota square. And applying a plus b into a minus b format over here. So the formula is a square minus b square. So here a is iota. So a square minus b square. So that is minus 1 minus 16. That is minus 17. So this is minus 1 by 17. And iota square is negative 1. So this is also cancelled out with this. So we have 2 pi into, these two cancelled out, 0. So the value for the given integral is 0. Okay, thank you.